Bismillahirrahmanirrahim. Start with the name of Allah, the most beneficent and merciful. Today, I am going to introduce you a little project. This is basically a lab project, and the project is related to power system, transmission, and distribution. In this project, we mainly focused on uh, the effect of reactive power on the system. Uh, what are we doing here? Here is a generator. Let me introduce you the simple network. Here is a generator which is slack type. Uh, we we may say it a swing generator, and it is connected to a bus number 1, which is rated to 132 kV. After that, a step down transformer is used to convert 132 kV to 11 kV. Now we are getting 11 kV on bus 2. After that, we have a transmission line, or we may say it distribution. uh, Actually, our main focus was on transmission and distribution system, so I take this generator as a source of power. Basically, this is not a generator. Behind this, there is a full network of transmission which is giving us power at the rated voltage of 132 kV. Normally, we do not use generation level up to 132 kV, but here here we was uh, having a need to supply this whole circuit. That's why I used a generator which is giving us 132 kV, uh, which is giving us power on 132 kV. But actually this is not a generator. This is behind this there is a complete circuit. We are assuming that that circuit is giving us power on 132 kV. Okay. After that, we are converting here 132 kV to 11 kV. So what we are doing here, we are converting the 132 kV to a primary distribution voltage level, which is 11 kV. After that, from bus number 2 to bus number 3, and same bus number 2 to bus number 5, and from here bus number 3 to bus number 5, we have this whole uh, we have this whole portion of primary distribution. This is our primary. As we know that our primary distribution voltage level is 11 kV. That's why here we will be having in this whole circuit, from bus number 2 to bus number 3, and here bus number 5, we will be having 11 kV. Okay. after that After that, what we are doing here, we are converting this 11 kV from this transformer. This transformer is converting 11 kV to 230 voltage. Basically, we are giving here in kV, so I gave this value 0.23 kV, which is mean 230 voltage. So what we are doing here, we are converting from primary distribution to secondary distribution level. We are converting voltage from primary distribution to secondary distribution level, and which are 230 voltage. We are repeating same this procedure here, converting from bus number 3 where is 11 kV voltage. These are nominal voltage, but due to line losses we are having here 10.74 kV, and we are getting our bus number 4 to 30 voltage. After that we connected a load which have active power 10 megawatt and reactive power 50 megawatt, and same here 30 megawatt and 50 megawatt. So firstly I will here I also connected a capacitor bank which is which is rated at 67 megawatt. Now it is not showing its value, but when it will be connected in system it will show its value. So this is the complete circuit which I am going to explain in simulation mode, where we will see its different impacts on power system. When we have more reactive power in system, we will see that there are more losses, there are more voltage drop on system, and our system will be uh, demanding more power from our generating side, which is inefficient, and our losses will be also high. So our whole system will not working properly, or we may say that it will be working with low efficiency. And after, when I will connect this power bank capacitor bank to the system, our reactive power compensation will be done by this capacitor bank, and our losses will be less, and also our uh, line voltage drop will be improved. So what we are doing, basically we are seeing the effect of reactive power on the system, and we are also observing what is the benefits of reactive power compensation on our system. So let's proceed for simulation. Here is the simulation. Now as you see, I have not connected capacitor bank in the system. Here in green arrows this is the active power, and in blue arrows this is the reactive power. We can see that our whole power is coming from generating side, and if we observe, our active power demand is 30 megawatt and 10 megawatt. Basically it is demanded from the load side total 40 megawatt, but our generating system is producing 47 megawatt. So where is the 7 megawatt? We did not demanded 7 megawatt, but actually these 7 megawatt are uh, appearing in the form of losses. If we observe line losses, in this line we have we have 4 megawatt losses, and in this line we have 3 megawatt losses, and in this line we have 0 megawatt, because there is no uh, generator on this side. So we do not need to uh, we have alternative paths, this and this, so power will not flow through this way. If this is flowing power from this way, then it will be very minute losses which are less than megawatt, or it may be kilowatt. So that's why it is not showing here its losses, but it again it will, there will be some losses, but in minute value. That's why it is not showing here. If we convert it into decimal point value, then it will show the losses in points. So what we are seeing here, our main focus was on voltage and power losses. So you can see that due to our more reactive demand, here 50 megawatt and here 50 megawatt, Due to this, what we are gaining here, our system is giving us the total loss of 7 megawatt, 4 megawatt and 3 megawatt. And the other thing is also we can see that our bus voltages, our voltages on bus 5 is 10.12 kV. On bus 6 we were rated it 0.23, but we are getting 0.22, means 10 volt drop here. Same here, we can see that to 220 voltage we are gaining, and here 10.20 kV. Although we were rated here for 11 kV, but due to line losses and line drops, uh, due to excessive power demand of reactive power, we are taking this voltage here. Now what we will do, we will just uh, introduce capacitor bank in the system, and we'll see the effect of the capacitor bank in the system. Basically we are now going to compensate this reactive power which is demanding by the load. And one more thing, we are not actually compensating 100%, we are just compensating 67%, or you may say that 70% of the total demand. Although there will be some demand from generation side, but actually we our main concern is to view the uh, total impact of reactive power compensation. So if we convert this 67 megawatt capacitor with 100 megawatt, so it will be work more finely and more losses will be minimized. So let's introduce this capacitor bank in the system. Now I am injecting this capacitor bank in the system, and what we'll do, it is just giving reactive power. You may see it is not giving active power, just injecting reactive power to the system, and it is rated at 66.70. You may see that our actual demand was 100 megawatt, and we injected the capacitor power of 66 megawatt. So what are the impact of this injection? Let's see. First, observe, line voltages are improved. We were given rated voltage or nominal voltage to 30 voltage, and we are taking to 30 voltage on output buses of load. So this is our basically demand which is fulfilling. Our main concern was voltages should be 230 on load side, and this is giving us 230 voltage on load side. And here you can also see that the voltage is improved from 10.2 to 10.74 kV. There are again some drops in line, but these drops are became less due to our reactive power compensation. And one more thing, you may see that our line losses became 2 megawatt only. Firstly these were 7 megawatt, so now we improved from 7 megawatt to 2 megawatt. So we minimized 5 megawatt losses to the system. And also the power demand from generation side is also reduced. Our basic demand was 40 megawatt, and now due to 2 megawatt losses our generator is producing 42 megawatt. And the second thing is this, also the reactive power demand from system is also reduced due to this reactive power injection. So these were the little lab introduction about the importance of reactive power compensation, and we also see the effect of reactive power on the system. Now you may observe again these these result in in an instance when I will open this capacitor bank and when I will connect this capacitor bank. These are the results when I opened this capacitor bank, and after that these are the results when I injected this capacitor bank into the system. So thank you for watching.